Hi, in this lesson, we are going to discuss about the concept of links in Linux. Let us try to understand what is a link. Like in programming languages, link is a pointer pointing to a file or a directory. Creating a link in Linux is a kind of a shortcut to a file or creating an alias name for an already existing file location. In Linux or Unix, we can create two types of links. The first one is called as the soft link or also called as the symbolic link, and the second one is called as the hard link. Before we understand the concept of links in detail, let us try to understand the concept of inode number and inode. The inode number is a unique number that is assigned for all the files and directories in the Linux file system. Whenever a file is created, along with the file name, a unique inode number is assigned to the file. The inode number in turn points to another data structure that holds the information about the file and the directory. Those information is also known as the metadata. Generally, the user uses the file name to access a particular file, but internally, every file is mapped with an inode number. The file name and the inode number is stored in a table called as the directory entry. The metadata of each and every file is separately stored in another data structure called the inode. The inode contains all other information with respect to that file. Now let's try to understand the concept of inode in Linux. The inode is a data structure that holds all the information with respect to each and every file and directories in the Linux file system. This inode is also known as metadata. This data structure contains information such as the user ID of the file, the group ID of the file size, the date of creation, permissions, etc. This diagram gives us the relationship between the inode number and the inode. As you can see here, the Linux file system maintains a special table called as the directory table. Within the directory table, it maintains the name of the file and the associated inode number. So each and every file and directories in the Linux file system will have an associated inode number. The inode number in turn points to another data structure which is called as the inode. So for every inode number, there would be one inode associated with it. As we discussed earlier, the inode in turn keeps track of all other information with respect to the file such as the owner or the group ID of the file, the permission, the timestamp of creation, the file size, etc. The inode also maintains the block addresses in which the actual data block would be present. Now, with this knowledge, we will try to understand the concept of hard link and soft link. The hard link points to the inode number of the original file. They points to the same physical location as the original file. So whenever the hard links are created on the original file, an additional pointer is created that points to the inode number of the original file. For example, if the original file has the inode number 123, the hard link will also point to the same inode number, that is 123. The consequence of this configuration is that as the original file and the hard link has the same inode number, they point to the same inode. As we discussed earlier, the inode is the data structure that holds all other information with respect to that file. Hence, Whenever we access any information with respect to the hard link, it returns the same result as the original file. Let us try to understand hard link in practical. For the purpose of practical demonstration, let us create one sample file. Now, let us try to create a hard link on the file called sample. The syntax for creating the hard link is ln followed by the name of the file followed by the link name. Let us create one more hard link on the same file. Now let us check the inode number of the original file and the two links that we have created on the original file. As you can notice from this output, the inode number of the links and the original file is identical. This is because when the links are created, the links points to the inode number of the original file. Hence, they too have the same inode number. The consequence of this configuration is they hold the same data as the original file. Let us verify the content of link 1 and link 2. As you can notice from this, the link 1 is also containing the same data. Even the link 2 is also containing the same data. As link 1 and link 2 are pointing to the same inode number as the original file. Now let us try to append some data through the link. Now let us verify the content of link 2 and sample. Whatever the read or write operation that is performed through the link is reflected onto the same location that is pointed by the original file. Now let us check the inode number and the long listing of all the files and links once again. As you can notice, the size of the file has changed. So from this output, we can determine that it's not only the inode number, the permission of the file, the link count, the owner of the file, the group owner, the size of the file, and the timestamp of the file all are same, as the links are pointing to the same inode number as that of the original file, and the inode number in turn points to the inode of the original file. Let us see what happens if one of the link is removed. As you can notice from the output, the link count has reduced by 1. The link count gives us an idea about how many links pointing to the same inode number. Previously, there were 3 links pointing to the same inode number. Now, there are only 2 links that is pointing to the same inode number. Let us see what happens if we delete the original file. As you would have noticed here already, as we try to access the content from link 1 and sample, it showed that no such file or directory. But when we try to access the content through link 2, still the content is accessible. For this is, the link 2 is still pointing to the inode number of the sample file, and hence we are still able to access the same content which is present in the inode. Sometimes the hard links are created in order to maintain synchronous copies of the file. Here, the links gives us the notion of keeping a separate copies of the original file without creating a copy of the original file. The discussed earlier, the links will be pointing to the inode of the original file. One of the drawbacks of hard link is that the hard links cannot be created on the directories. If the hard links are created on the directories, it would create ambiguity in the Linux file system. Let us try to create one for a directory. As you can notice here, the Linux file system does not allow us to create hard link on the directories. Let us try to review the concept of hard link with the help of this diagram. As we had discussed earlier, the Linux file system maintains a table called as the directory table. The directory table consists of the name of the file followed by the inode number. And the inode number in turn points to the inode. And the inode number points to a data structure called as the inode. With this setup, when we create a hard link with the same inode number, that inode number would also point to the same inode. The consequence of this configuration is that whenever we access any information with respect to a particular file, the information present in that inode is what we see. Whenever we access any information with the help of an hard link, as the hard link also has the same inode number as that original file, we would be seeing the same data as that of the original file. Now, let us try to understand the concept of soft link. The soft link is essentially like creating shortcuts in the Windows operating system environment, as the shortcut points to the name of the file. Like hard link, any changes done through the shortcuts or the soft link would affect the original file. In hard links, in which we can still access the content through the links even if the original file is deleted, in soft link, we cannot access the content if the original file is removed. So let us try to understand the concept of soft link practically. For the purpose of practical demonstration, let us create one sample file. Now let us create a soft link on the sample file. The syntax for creating the soft link is ln followed by the option s followed by the name of the file followed by the link names. Let us create another link on the same file. Now let us verify the inode number and the permissions of sample and the link files. As you can notice here, the links are entirely a different file system object. They have their own inode numbers. Hence, the link count is shown as 1, as there is only one link pointing to the inode number. One other thing what we can notice here is the size of the links. As the soft link points to the name of the file, the size of the soft link is essentially the number of characters in the file name. Now, like we did in hardlink, let us try to add some data into the sample file. Now let us check the content through the file. Now let us check the content through the links. As you can notice that we can see the same change everywhere. Now let us try to remove one of the link. As long as the original file exists, we can still access the content through the other links. If the one link is removed, we can access the content through the other link as the link still points to the file name. Now let us try to add some data through the link. As you can notice here, whatever the changes that is been updated through the link, it updates the original file as the link points to the file. Now let us see what happens if we remove the original file. As you can notice here, even though the link 2 exists, we are still not able to access the content from the link. The reason behind this is, if the original file is deleted, The link no longer points to the original file. So such links are called as dangling pointers. Let us verify this. As you can see here, even though the link 2 exists, it is no longer pointing to the original file. So such kind of links are called as dangling pointer. If necessary, this link can be restored by creating another file with the same name. Let us see how it is done. As you can notice here, the link is restored. Now let us try to access the content of the sample file through the link 2. Here you can see it is showing the same content as that of the sample file. Since the soft link points to the name of the original file, renaming the original file would still result in a dangling pointer. As you can notice here, once again, the link between the soft link and the original file has been broken. So in this lesson, we have covered the concept of hard link and soft link. Hope you enjoyed. Thank you.